Good morning. Coming from you live from Stanford. My name is Paul Batchelor, and I'm assuming we're at the first slide, and I'm going to be talking to you guys about Csound, which is a project worked on. It's a Csound plugin I made a few months ago, and I'm hoping this presentation will I'll be able to talk about the what's, the hows, and the whys of this thing. So next slide, please. What is Csound? So Csound is a third-party Chuck plugin, affectionately known as a chuggin by the Chuck community, and it allows you to run Csound inside of Chuck. Prior to the creation of Csound, there have been ways of and methods of getting Chuck and Csound running together. And what they end up boiling down to is you have essentially Chuck and Csound running in as separate processes, and you have some sort of communication protocol like OSC or MIDI that you use to kind of glue them together. And the issue with this problem is no matter what you do, you're always going to get some sort of latency. And that's just inherent to how that works. But this is different in Csound because with Csound, we're using the Csound API inside of Chuck to explicitly control the Csound audio callback from Chuck. And what this allows us to do is create a kind of a seamless experience of control of Csound from Chuck with zero latency. In the next slide, please. I have a video, one of several that I'm going to show you in this presentation. But this sort of demonstrates what I mean by zero latency. So it is a Chuck patch that's you're going to hear two sounds, the same thing. One sounds in Chuck, and one sound it's a sine wave. The other sounds a complex strong instrument in Csound. So if you could just hit play on that video and tell me when it's done, I'll continue talking again. So what you're going to hear is just the two sounds are going to play together, and there's no latency. All right, great. We can go on to the next slide, which is kind of the backstory, the why of Csound. So some of you might know me. It's okay if you don't know me. So I am definitely I identify as the Csounder. I've been using Csound for many years at this point as my main compositional sound design tool. And I guess one day I was interested in just seeing how the other half lived, and I looked at Chuck for a few weeks. And after a few weeks using Chuck, kind of playing around, I found that there were some things that Chuck did that I quite liked, and there were some aspects to it. For instance, I liked the C-like syntax.
They all know you.
Oh, okay. Oh, great. People are aware of that. Oh, great. It's nice to be known. So yes, I do Csound. I make a lot of Csound things, and with Chuck, I liked the way Chuck kind of handled algorithmic composition. It had like a C++ syntax with kind of C-like control statements, if, else, while, etc., etc. You've got types, things you expect. You've got your ints, you've got floats, you've got strings, and I actually found that you've got complex types as well, in both complex and polar form. I haven't played with it yet. That's kind of interesting. And there's the live coding aspect, and there's the strong sense of timing. Chuck is built around time, and there's just, you could just go on and on about time. I I don't know, there's just a lot of cool things that I like, and I had a lot of fun playing with it. But the big downside with Chuck that I found was just sound quality, and it just pales in comparison to Csound. And when I talk about sound quality, I'm not talking about fidelity. I'm talking about sound from a compositional sound design perspective. In Csound, you know, we're blessed to have so many of these amazing opcodes. It's just there's so many opcodes, and we have such an expressive orchestral syntax in the orchestra. The syntax is just quite expressive, and it allows you to really fine-tune and design sounds. And in Chuck, you really don't have that kind of expressiveness for designing how the patching of the sounds. And you don't, and the unit generators, I mean, they're lackluster. There's a lot to be desired. So as a composer, I really couldn't justify using just Chuck, just because I couldn't get the sounds that I wanted, and that was important to me. So I set about trying to kind of hybridize these two languages together, because I felt like they could work together. So I wanted an environment where I could get the sounds of Csound with Chuck's control, and Csound was born. So next slide, please. We should be at usage. So there are a couple, for me, there were a couple of few use cases that I wanted, and a few things I wanted to be able to do. So first things first, CSD compilation. I wanted to be able to compile a Csound CSD and have it run in Chuck. Pretty basic, but that's what that first thing I wanted to do. I also wanted to be able to kind of embed Csound code inside of Chuck and be able to just actually write Csound code and Chuck code at the same time, have them work together. So so we could accomplish this using orchestra evaluation, which is a new feature in Csound 6 with real-time score event scheduling. And I wanted to be able to also access the to utilize the Chuck VM and utilize kind of the live coding aspects and the idea of shreds and having blocks of code running concurrently together. And so I wanted to be able to send score events across multiple shreds and inter-shred communication using only one instance of Csound. And finally, I wanted to be able to have Csound and process Chuck audio and essentially make Csound turn into any unit generator and utilize all of the sonic processors and the opcodes, the cool opcodes that Csound has in Chuck. At this point, I've been able to do all of these, and I have some really simple examples of all these being done. So if I could go to the next slide, please. Right here, we have an example of compiling a CSD in Csound. It's 3 lines of Chuck code. So basically, you create your Csound object, you compile it, and you have it run for 283 seconds. So the next slide, I actually have a video of what this would sound like. And by the way, I apologize for the quality, the YouTube quality of the audio, but I hope you will understand. So you get the main idea. So we're on the video, and you can click play and hear what it sounds like, and just let me know when you're done. Cool. So as you can see, like if you noticed, like the bottom half of the screen, it looks like a Csound console with Csound output, except that so it looks like Csound, it sounds like Csound, but the audio itself is actually Chuck. So if that makes any sense. On the next slide, after that video, we have a slightly more complicated example. So compiling CSVs is all good, but if we're like, doing on-the-fly coding, or we want to like write pieces that really meld both, we want to be able to, write Csound code alongside Chuck code. So this example does that. So once again, we have our Csound C going to the DAC. We're compiling a Csound document, and this is sort of the design decision I made. It's a blank with special CS options and stuff, but it's still mandatory. And I found from internally this was just an easier, simpler thing to do. So that's why it's there. So we're making a string, and this string is our orchestra. We're evaluating it, and then we are sending an input message, a score event, and we're running for 10 seconds. And this, if you does what you expect, it's your hello world 440 signs. So in the next slide, we'll run it, and if you play the video, it'll be what you kind of expect. So you can play the next video and kind of see this in action. All right, so for the next slide, dealing with sending score events and having multiple shreds, multiple files, sending node events to one instance of Csound. This is a slightly more complicated example, so I'm not going to show the code for it. You'll see it in the video, but I don't have a slide of this because there are 3 files. All these examples, by the way, are available in the GitHub repository. So including the template and everything I have in this presentation. So you can have a look at the project and see how it works. But essentially, the solution to this problem, so the problem itself is, I have all these shreds and I have all these programs running at the same time. And the way we're doing things now, if we were to have 2 files running, we'd be having 2 instances of Csound, and that, if we had 3 shreds, we'd have 3 instances of Csound. That's just not CPU efficient. So what we're doing, the solution for this is actually to do in Chuck, we're actually creating a wrapper of the wrapper, if that makes sense. We are wrapping our Csound object in a public class in Chuck with a static instance of Csound. And this becomes publicly available to other shreds to see. So in this next video, what I have is 3 files are going to be run. So we've got this wrapper, this engine that we make. And then we run a note launcher, followed by another note launcher. And these 2 files are being run at arbitrary times, and I start them at arbitrary times, and they're playing 2 different sounds. And you'll notice that when you hit go, Csound handles this just fine. Csound's really good at just like handling multiple notes in this way, and it kind of rocks. So you can hit play on this video and just tell me when it's over, and you can hear this in action. Alright, cool. So for my final example, shows it in the next slide, shows how you can use Csound, you can actually send stuff into Csound to be processed. And I really like, this is my favorite because there's just something great about like setting up the routing and then building the instrument later. I don't know, it's just the way this flows on the page is just really fascinating to me. But it's essentially what's happening in Chuck. We are creating a sawtooth oscillator. We're putting it through a low-pass filter, and we are modulating the frequency with some sort of Randage sample and hold. And so what we're doing is we're sending that to Csound, and what Csound is doing, Csound is taking that and putting it through the waveset opcode, and it's creating some wonderful time stretch, goodness, and it's kind of it's a unit generator that doesn't exist in Chuck, and we're making it exist today thanks to Csound. The way we're accomplishing this is with an A-rate channel that we've predefined in Csound in the source code. Pay no attention to the name of the channel. I don't like it right now. I'm meaning to change it, but because it really doesn't. It's not really Chuck out. That's kind of a confusing name, but essentially the concept is we're using an A-rate channel and to get the input, and we're setting the output. And once again, it's going to an orchestra. This is a string. We're evaluating it, and then we're running the program. So if you go to the next slide, this is an example of what this would sound like. And so you can hit play and tell me when it's done. Cool. So that's basically Csound in a nutshell. So where we're at now and where's Csound going? So at the moment, I feel pretty confident that Csound works. Like it's like a proof of concept. I've got enough things working, and it's interesting to me. But as you can see, these aren't musical. They're really kind of tests. And so the next step for me is going to be is scale. So I want to be able to write longer pieces, write compositions using Csound, and find bugs along the way and fix them, and possibly if people are interested, get user feedback and have Csound grow that way. So that's where it's headed, and that is everything I have to show you today. So on the next slide, so that's basically everything I have. Once again, the project, the link for the GitHub project is there at my website. Load that. And if you want to email me with any questions related to Csound or something like that, you can use one of those. This is paulbatchelor@gmail.com, or my Karma email address, pbatch@karma.stanford.edu. So that's what I got for you. So thank you. Are there any questions?
So probably
type applause.
we wait for questions, and probably someone would like to ask a question to Paul. I will type it, or probably you would like to do it by yourself.
I have a
Alex?
question. Yeah. If he thinks, is it worse to learn a second language besides Csound to learn Chuck?
And for learning second language besides
Csound, to learn Chuck. So
besides Chuck, right?
No, besides Csound.
Besides Csound.
Because Is there something I can do with Chuck I can't do with Csound? No, it's hard to.
Alex Hoffman.
It's just one Alex here.
Oh, is it? Excuse me. Question is it worth learning a second language besides Csound? Well, to me, I think it is. I don't think it's necessary to use it, but I think in general, learning different programming languages, it gives you different ways of thinking, and certainly, in my experience using Chuck has definitely changed. There's just a different kind of thinking that goes on, and I'm sure that it's helpful somewhere down the process. There's certainly a different way of thinking, with my experience with Faust or Super Collider or PD that just has. Is there something unique about Chuck that is not in Csound already? I think the unique things about Chuck are really in the design of the language and the expression. I think it's really, from a sound standpoint, no, but from an organizational standpoint, I think it's just it can be an easier way of looking at approaching a composition. But that's a good question. There's a lot of things that aren't similar things that you can already do in Csound, and if you're happy with that, then that's fine.
Thank you.
So, any questions?
I think there is also the possibility to use only opcodes instead of the whole Csound language. My question would be, would this for him perhaps be a good approach?
So
you can use, I think, the opcodes as units, also in other languages.
you can use opcodes as
units in other
as
languages.
units, yes. As units. And sorry, anyone?
Sorry?
You can use opcodes as units.
In Chuck
In
instead
Chuck.
of the whole
in
Csound
Chuck,
language.
yeah.
Yes, independently of the Csound language.
Instead of,
Whole Csound. Yeah.
yes, instead of Csound.
No?
Paul actually has written a language, though. It's in the new book.
Huh?
It's called SoundPipe, and it's just
Oh,
the Csound codes. I'll let him
Yeah,
explain about that.
so that is quite possible, and I've actually done that in some projects. So I'm interpreting is that I'm interpreting this, and I hope I get this right. And so instead of using Csound and building instruments in Csound, why not just extract the source, the actual opcode itself out of Csound and put it and make it a Chuck unit generator? Okay, yeah. So I've done it. So yes, you totally can, and it definitely makes things a lot easier. You can. So I have this project I've been working on that. Some of you may know that I've been actually doing this. I've been extracting opcodes, going into the source code and extracting these algorithms, and just putting them in putting them in a smaller place. And what this allows me to do is do exactly that. So on my GitHub, I actually have some examples.
I think he has Reverb
There,
SC running in Chuck all by itself.
Yes, I have. Yes. So, for instance, I'm a sucker for the Sean Costello Reverb SC. So I've actually created a chugging. So I have the sound of Reverb SC in Chuck that I can use. So yes, so Reverb SC doesn't need, for me, I no longer need to use the Csound engine to get reverb SC. So if I just want that reverb, I have it as a plugin now that I made.
So, any questions anymore? Okay. Thank you for answers. And hope to see you next
Thank you.
ICSC.
Well, thank you for having me. Yes, I hope so too. So, yes, enjoy the rest of your day, guys. Bye.